Okay, let's get into this. We're doing a deep dive on a really significant breakthrough for vision language model agents.
Right. It's a new framework called GTR-Turbo, and it comes from researchers at Tsinghua University and Tencent AI Lab.
And our mission today is to unpack how they solved one of the biggest, most expensive problems in RL training for these agents.
Exactly. The reliance on external oracles. I mean, training agents for complex multi-step tasks like embodied navigation or math reasoning. It's just brutally difficult.
Because the rewards are so sparse, right? The agent usually fails long before it gets any kind of positive signal.
Precisely. And that leads to this phenomenon the paper calls thought collapse.
And for you, what that means is the VLM might start with a good plan, but then it just gets lost. It forgets the goal, starts repeating itself because that final success signal is just too far away.
And the old solution, guided thought reinforcement or GPR, tried to fix this by calling out to external models, like GPT or Gemini.
Asking for step-by-step corrections. It worked, but the cost was just staggering.
It was. The sources mention one GTR experiment costing over $300 and taking almost 200 hours to run.
GTR-Turbo gets rid of that completely. It introduces this idea of a secretly free teacher. No more external API calls.
Which is a massive shift.
But wait a minute, how can a model teach itself effectively? Aren't you just running the risk of it reinforcing its own bad habits, its own errors?
That's the really elegant part of this. It's not teaching itself from its current state. Instead of calling an outside expert, GTR-Turbo looks at its own history.
Its own history.
Yeah, it merges the weights of historical checkpoints that were created during the training process.
Okay, but usually when you just smash model weights together, you get catastrophic interference. I mean, a model that's worse than any of its parts. How do they solve that?
They used a really clever technique called ties merging.
Ties merging.
It stands for trim, elect sign, and merge. It's a method that selectively combines the parameters. Basically, it finds the positive changes from past successful runs and merges those while filtering out the noise.
So you end up with a merged model that's actually more stable and even performs a little better than the agent that's currently training.
Exactly. And that merged model becomes the free, internal, self-evolving teacher.
So now you have the teacher. How does the student agent actually learn from it?
They tested two methods for that. The first was a standard supervised fine-tuning loss. The second was something much more sophisticated.
Which was?
Soft logic distillation. They did this by minimizing reverse KL divergence.
And that one was the clear winner.
By far. Because SFT guidance just gives you a single correct next token. It's a very narrow signal.
But the KL divergence approach, what does that do differently?
Well, it captures the teacher's entire probability distribution over all the possible tokens. So it's not just telling the agent what the right answer is.
It's showing it why other answers are wrong.
Exactly. You get a whole map of the teacher's reasoning space. It makes the learning so much richer and more efficient.
And the results. I mean, this is where it gets really impressive. GTR-Turbo performs just as well, sometimes even better, than the original GTR.
But with these incredible resource savings.
Yeah, training time cut in half. And compute cost slashed by 60%. The example they give, dropping from about $300 a run to $115, that's a game changer.
It really is. That makes this kind of research accessible to so many more labs, not just big tech.
And they proved it on seriously tough tasks. In the Points24 card game, which needs both visual recognition and sharp math skills, the KL version of GTR-Turbo got state-of-the-art results.
It even beat out much larger commercial models.
They also use the ALFWorld simulator. 50 steps in an embodied environment is like a marathon for an agent's memory and planning.
Even there, GTR-Turbo showed really stable, rapid improvement, all based on its own exploration.
So it really does offer this new paradigm, a scalable, self-sufficient way to train these VLM agents.
It moves the expertise from some expensive black box API in the cloud to a process that's completely internal.
So, to wrap this up, what's the big takeaway for you? The paper does mention one limitation, that the base model still needs to have a certain level of capability to get started.
Right. It has to be good enough to explore and find some positive rewards to seed that merging process.
Which brings up a really provocative thought. If foundation models, like the Qwen 3 VL8B they mentioned, keep getting more and more capable right out of the box,
Then you have to ask,
yeah,
will a method like GTR-Turbo eventually make proprietary teacher APIs completely obsolete for this kind of specialized fine-tuning? We might be watching the first steps of a truly self-evolving agent.